Let me walk you through my test setup for underwater hair. I simulated pig head primitive geometry to have some deformation on it. I did a groom on rest geometry to have some long hair guides for simulation. Then I am using guide deform node to apply my animation to the groom. As my collision geo I am using ground plane, head and same test object as I did for my skin simulation. I am remeshing and caching pig head geometry for better collisions. I am adding glue to animation attribute to my hair guides and caching them. In DOPS I have my collision geometry, wire solver with SOP solver and pyro solver for my velocity field. On the drag tab of wire object, I set external velocity field name to match SOP vector field name. This is the velocity field created by pyro solver. In SOP solver I am creating density attribute for hair guides and I am using that attribute to blend smoothed velocity in the high density areas. This way clumped and high density points will have averaged velocity, but velocity will be preserved for low density areas. This also works as fake self collisions. Bounding box for pyro simulation is created by merging bounding boxes created every 10 frames and padded to fit my animation into bounding box. B-box and centroid expressions are used to set size and position of fluid container. I am using gas field VOP to add curl noise to my velocity field. Length of velocity vectors is used to multiply noise amplitude. Faster motion will introduce more turbulence. I turn on visualization on velocity to tweak my velocity field and noise settings. Last, check if the velocity field and collisions are working, and I am ready to cache my simulation. Now my simulation is cached, and I can check for penetrations and stretched segments. To generate render hair, I will unlock Guide Deform tool and override point positions on my animated hair guides with my simulated hair guides.